Now I am solving a vector space question, which is from linear algebra. The question is occurred in CSIR net December 2011. The question is based on the from dimension calculation. The question is the dimension of the vector space of all symmetric matrix of order n cross n, which n greater than or equal to with real entities and trace is equal to 0. We have to calculate the dimension. Then how to calculate actual dimension? Dimension is nothing but number of linearly independent sets which spans the vector space, which is nothing but if S is a set, let's suppose x1 x2 dot 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 xn, then if x1 x2 xn are linearly independent and x1 and linear span of S is equal to B, then we can say that S is the basis of the vector space B, and the number of element is the dimension of the vector space S, vector space B. Now we have to actually calculate the dimension of the vector space of symmetric matrix space. Symmetric matrix is nothing but, let's suppose M is a matrix which entities are, since this is n cross n matrix, the elements are a11 a12 up to a1n and a21 a22 up to a2n, an1 an2 up to ann. Symmetric matrix is nothing but an1 element and aij equal to aji for all I j is equal to 1 to n. This is called symmetric matrix. Then we have to find symmetric matrix and another condition which trace is 0. If this matrix is symmetric matrix, then how many linearly independent sets of vector which generates the vector m? We can actually see that the a1n and an1 are same. Then similarly, here the element a1n minus 1 and here element an minus 1, a1n minus 1 and an minus 1 comma here element n minus 1 and here element a n comma 2 are same. Similarly, all the elements which is, let's suppose there is a mirror, then all the elements from here and here are the same, the mirror image of this. Then how can we count the number of linearly independent linear points? In the right top corner there is one element 1 and second is 2 up to the diagonal element is n. The sum of n natural number is n into n plus 1 upon 2. This is the dimension of the symmetric matrix space, symmetric matrices. Now we have to add another condition, which is trace is equal to 0. We know that the linearly independent trace is 0. That means a11 plus a12 up to a22 up to ann is equal to 0. This is another condition. Then the dimension, here the on linearly independent condition. Then the dimension of the symmetric matrices which trace equal to 0 is the total dimension minus linearly independent cases. So n into n plus 1 upon 2 minus 1, that is n squared plus n by 2 minus 1. C is the right answer. Okay. Next move to the second question. This is the same type of questions. We have to calculate actually the dimension of Hn. What is Hn? Hn be the elements of Aij, elements of the matrix Aij, such that that is Aij. The condition is Aij is equal to Ars, where I plus j is equal to r plus s. We have to calculate the dimension of this. How can we calculate? We have to calculate the linearly independent sets. The matrix is Hn A11, A12 up to A1n, here An1 up to Ann. Then we have to actually check how many such I plus j that sum is equal. If this is n cross n matrix, right, then the minimum number, the minimum sums, we have to actually, if we calculate the number of Aij and Ars, Aij is the number of possible classes of Aij, then we can actually find the dimension of the Hn. The smallest value of I plus j, this is 1 plus 1, minimum of I plus j 1 plus 1 is equal to 2, and maximum of I plus j is equal to n plus n is equal to 2n. Then the I plus j is lying between 2 to n, 2n. The number of integers lying between 2 to 2n is the dimension of the Hn. How? Because they are same, Aij and Ars. If we calculate the number of possibles of Aij value, then we can say that this is the dimension of the matrix space of matrix. The integer value in between 2, 2n is nothing but 2n minus 2 plus 1 is equal to 2n minus 1. This is 2n minus 1 is the right answer. Again I am saying how I calculate this dimension. Hn be a space of all matrices with entries R, and Aij is equal to Ars, where I plus j is equal to r plus s, where I, j, Rs belongs to 1 to n. Then the dimension of the Hn matrix. Hn is nothing but this matrix. Then I am willing to do I plus j is equal to r plus s, and the cases for I and j, that means if we find a number of Aij which is linearly independent, then we have to actually calculate I plus j. The minimum possible values of I plus j is equal to 2, and maximum cases possible of I plus j is equal to 2n. That means Aij, where I plus j is lie between 2, 2n. Then how many integers lie between 2, 2n? That means 2n minus 2 plus 1, and that means 2n minus 1. That is the dimension of Hn is 2n minus 1. Thank you.